Welcome back. My name is Maysie Calzone, and this is Maysie's Algebra Initiative. Today we are going over the Unit 5 topics, and this includes system of equations, and we're going to learn how to solve these system of equations through substitution and elimination. And the next topic, and the final topic for this lesson, is inequalities. Okay, let's get started. Okay, a system of equations is two equations and they overlap on a graph, and on the point at which they overlap, or points, that coordinate point set will satisfy both equations. It will be correct in both equations. So the most common is there's one solution. The two lines cross in one point. There's also a scenario of no solution. These are parallel lines. That means they run next to each other parallel and they will never cross. They have the same slope. And infinitely many solutions means that the two equations are the same line and they overlap on every single point ever. Okay. So we're going to start the first of the two ways to solve for a system of equations, or the coordinate point that satisfies both, and we're going to determine if these two sets of equations have no solution, infinitely many solutions, or no solutions. Now, the first way we do this is through substitution. Step 1 of substitution is to make equal to a single variable each equation. It has to be the same variable. So in this case, it's already done for you. Both equations are set equal to y by itself. And now our second step is to I call this the substitute step, stub equations, and this is setting equal to each other. You're substituting the y for the other equation. Like this. Now we solve for first variable. Just like we would solve for any other variable, combine like terms, so I did this all in one step. These eliminate. Subtracting the 1 to both sides eliminates this 1, and minusing the 4x subtracts the x from this side, or eliminates it. So we get negative x is equal to negative 4, so x is equal to a positive 4. And now we solve for the other one. To solve for y, we do this by plugging it into one of the original equations, so let's do that. So y is equal to, let's plug x in, so 3 times 4, I took the top equation, plus 1. Y is equal to 13. And now we're going to check, because it is very easy to screw up the algebra on these. Check. And the way we checked is by plugging in our coordinate point. We found that it was 4, 13, and plugging into both equations, and they should both work out. Let's start with the top one. So 13 for y is equal to 3 times 4 plus 1. So that's 12 plus 1 is equal to 13. That's 13 equal to 13. Woo! Now let's try with the second equation. Y is equal to, 13. Excuse me. 13 is equal to 4 times 4 minus 3. So 13 is equal to 16 minus 3. That's 13 equals 13. Check. We know that this is our answer. This is the coordinate point where these two lines will intersect, and they have one solution. Okay, this is the second kind of solving a system of equations, and it is called elimination because we eliminate variables. The first way we have to do this is by stacking the equations. I like to call them stacking because you put them on top of each other. And to eliminate a variable, they have to have the same coefficient. So we'll write coefficient equal, and then opposite sign. So I'm going to get rid of the x first. No, I'm going to get rid of the y first. So the y, they have opposite signs. It's a positive one on the top, it's negative on the bottom, but they don't have the same coefficient. How do I change this? Well, I'll tell you. So I'm going to multiply the entire equation on the bottom times 2. So I'm going to keep the top equation the same, and then multiplying by 2, we'll get that to a negative 2y. Now our second step is we add the equations. So x plus negative 3 is going to be negative 2x. These cancel out to be 0. Whole point of elimination, remember? And I add the 10s, that's going to be 20. I solve for x, so I divide by negative 2. X is equal to negative 10. Now my third step, well that was my third step, solve for x, or our first, or whatever you solve for first. I just solved for x first. And our fourth step is solve for y. And I do this by plugging back into one of the original equations, so x is going to become, I'm going to do this top equation. So it's going to be negative 10 plus 2y is equal to 10. Add 10, add 10, 2y is equal to 20, y is equal to 10. Now, let's check. And I check, uh-oh. Hey y'all, I just noticed one thing. See, when I was going to the check step in my head, I caught my mistake. When you do this step here, when I multiply by 2, you have to multiply everything. I multiplied everything but the 3x. I kept it as 3x. That should have been a 6x. And now we're going to redo it from this step. So I'm going to add them. See, I was thinking about checking, and I was going back through my work, and that happens. And this would have been caught by the check step. So that explains how important that is. Negative 5x is equal to 10, so x is going to be equal to, 20, and x is going to be equal to negative 4. Now I'm going to solve for y by plugging back into original equation. So negative 4 plus 2y is equal to 10 plus 4 plus 4, 2, those eliminate. 2y is equal to 14, so y is equal to 7. Now I'm going to check this by plugging the same way I did substitution. I plug my new coordinate, negative 4, negative 4 comma 7 into both equations. So negative 4 plus 2 times 7 is equal to 10. So negative 4 plus 14 is equal to 10. So that's 10 equals 10. That top one's good. Check. Let's check the bottom one. Negative 3 times negative 4 minus 7 is equal to 5. So that's going to be positive 12 minus 7 equals 5. 5 is equal to 5. Woo! And that's good. So we know our answer is going to be the coordinate negative 4 comma 7. And this, once again, is a one solution because we got 1 point. If it was no solutions, all the variables would cancel, and we would end up with an improper, we would end up with something like 5 equals 10. And that would be no solution. And if it was all solutions, the variables would cancel, and we'd end up with 10 equals 10. And when I mean the variables cancel, they cancel back here in this step when I was solving for the first variable or the second one. And this would be infinitely many. I'm just going to draw an infinity sign. Okay, here's some practice problems. Pause the video now to go over the practice problems, and then unpause the video to get the answers. And in this practice problems, you're going to determine the solution to the set of the equations by using elimination or substitution. Pausing the video now. Okay, here's the solutions and all the work. I have my check steps. On the top one, I did substitution. On the bottom one, I did elimination. And for number 1, I got the coordinate point -4, -1. And on the bottom, I got the coordinate point 2, -1. Okay, the second part of today's lesson is the inequalities, but I want to revisit that because I would wish to talk to you about the no solution and infinitely many. I feel like I didn't talk about that enough. Solution. How they would look. So, if I had an equation like x plus y is equal to 10 and y equals -x plus 7, let's see what happens when I try to solve for it. I'll do substitution. That one's already set to y. Let's set the top to y by subtracting the x, bring it over, so that'd be y equals -10. I mean, -x. Whoops. -x plus 10. And so these are our two equations I'm working with now. They're both equal to y, so I set them equal to each other. -x plus 7 is equal to -x plus 10. Let's combine like terms, add the x's to both sides. But those both eliminate each other. And now I'm left with 7 equals 10, which is not a true statement. So this has 0 solutions. Now let's look on the flip side. If I have y is equal to x plus 3 and 2y is equal to 2x plus 6. Let's once again solve this by substitution. Let's get y by itself over here. Let's divide it all by 2. So I'm going to end up with y equals x plus 3. And now let's set them equal to each other. X plus 3 is equal to x plus 3. I subtract the x's. They both cancel. Now I got 3 equals 3, which is a true statement. So this is going to have infinitely many solutions. Okay, now that that's cleared up, let's get back to learning about the next topic, which is inequalities. If I can find the slide. Here we go. So inequalities. Here are your 4 basic inequality graphs. If there is a solid line, like if I have, let me choose a different color. If it's a solid line, that means that there's an equal to in the inequality, as you can tell from these two. These two both had solid lines. And if there's no equal in the equality, it's just less than or greater than, it's going to be a dotted line. So dotted line for these two. And if y is less than something, it's going to be below the line. And if it's greater than something, it's going to be above the line. So here, for when y is greater, it's going to be above the line. And when y is less than, it's going to be below the line. That's how these are the base inequality graphs. If I graphed like y equals x and y is less than or equal to x, that's what it would look like, because those are all the solutions that if I plug those into here, they would fit this equation. It would all work out. Same with the other 3 graphs. And this is what you need to know, the basis. If there's a equal to in it, it's going to be a solid line. If there's no equal to in it, it's going to be dotted line. If it's less than, it's going to be below the graph. If it's greater than, it's going to be above the graph. Okay, here's the characteristics of a linear equality graph. The boundary lines are these lines right here. And A closed half plane is when the line is solid, so solid line. And an open half plane is when the line is dotted, so dotted. So there's just some quick characteristics. Okay, when I have two inequalities on a graph, the solution for both of those inequalities is where they overlap. If I treated them like a system of equations, their solution would be where their graphs overlap. So the way I would solve it out is by graphing each equation, shading it, and then seeing where they overlap. So the red is the first equation, the blue is the second, and the green is where they overlap. There is also examples of a no solution on here, which means that they never cross, and here's an example. And there's also infinitely many, which would look something like this. They would be the same line, and they would have the same inequality. Okay, here's some practice problems. You should graph the inequalities based on the characteristics you just learned and determine their solutions. Pause the video now and then unpause it when you're ready for the solutions. Okay, so here are my solutions. I graphed the two lines over here, I shaded them individually, and then I shaded in another color what their solution was. Awesome. Okay, thank you so much for watching. I hope you learned something new today. This is Maysie Calzone from Maysie's Algebra Initiative signing off.